We're going to learn a little bit more about the geometric transformation translation, which is a slide. And we're going to do that specifically by translating a point, a segment, and a polygon on a coordinate plane. So this first example is a point A. We're going to translate it 5 units to the right and 3 units down. So on my coordinate plane, I'm going to find point A, and I'm going to physically count on the grid 5 units to the right and 3 units down. And I'm going to draw that point, which is called the image, and I'm going to label it with an A and a prime symbol. And that distinguishes the difference between the original one, which was called the pre-image, A, and A prime, which is the image. I'm also going to, I did it on the coordinate plane, now I'm going to write the translation notation, which in my mind is like the rule. What did we just do? So with any sort of notation or rule, you always start with this x comma y, and you put this little arrow in which you read it as yields, and then this is where we write the algebraic rule. So the first part of the rule is what happened horizontally to that point when we translated it. Well, we moved it 5 units to the right. So I'm going to say x plus 5. Had I moved it to the left, I would have said x minus 5. The plus 5 determines that I am moving to the right or towards the positive numbers. And then I'm going to write the rule for the y. And above it said 3 units down, so I'm going to say minus 3. If I had moved it 3 units up, I would have written it as plus 3. Now I also need to list the coordinates of the pre-image and the image. The pre-image is A, and it was located at -2, 2. And the image, A prime, is located at +3, -1. I want to show you one other technique that you can use if you're not graphing it. If you're not actually doing the transformation on a coordinate plane, you can use the translation notation to help you figure out the new coordinates. So let me explain what I mean by that. So if I know that point A is located at -2, 2, and I have my translation rule written as x plus 5, y minus 3, I can actually take that information and apply it to these coordinates. So for example, my x coordinate is -2. I can take that rule and I can add 5 to it. And I know that -2 plus 5 is 3. So the x coordinate of A prime should be 3. I'm going to do the same thing with the y coordinate, but I'm going to apply this rule here, which is -3. So I'm going to do 2 minus 3, which is -1. So the y coordinate of A prime would be -1. So it's another way to do it, or it's also a way to check your work, because you notice that the A prime that I got from my coordinate graph is exactly the same as the one when I applied the rule or the translation notation. So now let's try an example in which we translate a line segment. We're going to translate segment ST 4 units to the left and 2 units up. So I'm going to start with point S, and I'm going to, on my grid, physically count 4 units to the left, and I'm able to do that, by the way, because each of these is 1. You need to be careful if you're doing it with a graph to make sure that you look at the scale. See how your intervals are labeled. Okay, so 4 units to the left, I'm going to go over 4, and then 2 units up means I'm going to go here. So I'm going to write S prime right here to label that one. Then I'm going to do the same translation with point T, 4 units to the left and 2 units up. So T prime is actually going to be on the x-axis. And this whole segment is translated, not just those 2 points. So I need to go ahead, and I'm not very good at drawing straight lines with this stylus, but you get the idea that the whole line segment was translated, not just the endpoints. All right, so I did it on the coordinate plane, and now let's write the translation notation. X comma y yields So first I'm going to write the X rule, which is 4 units to the left. So again, going to the left means I'm going to do -4. And then the vertical rule, or the Y coordinate rule, 2 units up. So I'm going to say Y plus 2. And now I need to list the coordinates, or the ordered pairs, for the pre-image and the image. So S is 3, 2. T is 1, -2. S prime would be -1, +4. And T prime is -3, 0. I'm just going to quickly check my work by looking at that translation notation to make sure. So looking at S, if I started with 3 as my X coordinate and I subtracted 4, I would get -1. And I did, so that's good. And then my Y coordinate is 2, and I'm going to add 2 to that. 2 plus 2 is 4. So S prime is at -1, 4. I just checked it. T was at 1, -2. So now I'm going to apply the rule. 1 minus 4 is -3. And then -2 is the Y coordinate, and I'm going to add 2 to that, which is 0. So T prime should be at -3, 0, and it is. The last example, we're going to translate an entire polygon, and in this case, it's a rectangle, JKLM. So instead of having the directions written out with words, now it's written as a translation notation, and we have to interpret what does that mean in terms of words. So let's start with the X plus 5. We know that that is going to tell us which direction to move it or to slide it, left or right. So because it's a plus, that means we're going to translate it 5 units to the right. The +5 means to the right. And now we're going to look at the Y direction. The Y minus 1 means that we're also going to translate it 1 unit down. So that entire rectangle and all the points associated with it will slide 5 units right and 1 unit down. So now I'm actually going to do that on my graph. So I'll start with the J. J is going to go 5 units to the right and 1 unit down. So J prime is going to go right here on the y-axis. Let's do the same thing with K. 5 units to the right and 1 unit down. There's K prime. L, 5 units to the right and 1 unit down. And same translation with M. 5 units to the right and 1 unit down. So M prime is going to also be on the y-axis. Now, all the points in between are also translated. But since I got the 4 vertices, I can go ahead and just fill it in. Okay, so the last thing I need to do is to list the coordinate points of both the pre-image and the image. So the pre-image is JKLM. It looks like J is at, just want to make sure, -5, +5. K is 0, 5, because it's on the y-axis. L is 0, 2. And M is -5, +2. And now I need to list the coordinates of the image. J prime is located at 0, 4. K prime is 5, 4. L prime is 5, 1. And M prime would be 0, 1. Again, I can always use this rule to check my work. So I'm just going to do that just to make sure. So if I add 5 to -5 in J, I would get 0. And if I subtract 1 from 5, I get 4. So J prime is at 0, 4, and that checks with what I did on my coordinate plane. K is at 0, 5. So I'm going to start with the 0 here, and I'm going to add 5. So that should be 5. And then 5 minus 1 is 4. So K prime is at 5, 4, and that one also checks. L prime, I'm going to add 5 to 0, so 5. And then I have a 2 here, and I'm going to subtract 1. So 1. L prime is at 5, 1, and that one also checks. Lastly, let's figure out M prime. M is at negative 5 for the x coordinate, and if I add 5 to that, I get 0. And 2 is the y coordinate, and if I subtract 1, I get 1. So M prime also checks. I hope that you're feeling a little bit better about how to translate points, segments, and polygons, and describe the transformations with words, with the translation notation, and to do so on a coordinate plane, as well as list out the coordinate points.